To identify a ground fault circuit interrupter receptacle, you can look for several key features. Firstly, check for two buttons labeled Test and Reset on the faceplate of the receptacle. Secondly, the faceplate should be clearly marked with the initials GFCI. Some ground fault circuit interrupter receptacles may have an indicator light that glows green when the ground fault circuit interrupter is functioning properly, or red when it has tripped. To verify ground fault circuit interrupter protection for multiple outlets, you will need to locate the ground fault circuit interrupter receptacle. Trace the electrical wire from the outlet near the pool back to its source. The ground fault circuit interrupter receptacle will typically be the first one in the circuit. Isolate the circuit by turning off the circuit breaker or fuse that supplies power to the outlet near the pool. Test the ground fault circuit interrupter by pressing the test button on the ground fault circuit interrupter receptacle. If the ground fault circuit interrupter is working properly, it will trip and cut off power to all outlets on the circuit. With the ground fault circuit interrupter tripped, check all other outlets on the circuit. They should not have power. Once you have confirmed ground fault circuit interrupter protection, press the reset button to restore power. Ground fault circuit interrupters should be tested regularly, for example monthly, to ensure proper operation. Never bypass or remove a ground fault circuit interrupter. Ground fault circuit interrupters should be installed by a qualified electrician. Maintain a safe distance, at least 6 feet, between electrical outlets and pools or hot tubs. When examining outlets to see if they are connected to a ground fault circuit interrupter, the first thing you should do is look at the receptacle itself. A ground fault circuit interrupter receptacle has a distinct appearance. You're looking for the test and reset buttons that are centrally located on the face of the receptacle. These buttons are the primary visual indicator that the receptacle is a ground fault circuit interrupter type. The test button is used to simulate a ground fault, which should cause the receptacle to trip, cutting off power. The reset button is used to restore power after a trip. Also, look for the letters GFCI somewhere on the receptacle face. This is another clear indication that it is a ground fault circuit interrupter receptacle. Sometimes this marking can be small, but it's usually present. After you've identified a potential ground fault circuit interrupter receptacle, you need to verify if it's protecting the outlets near the pool. If you find a ground fault circuit interrupter receptacle, it might be located centrally, serving multiple outlets, including the one near the pool. Go to the breaker panel and turn off the breaker that supplies power to the receptacle and the pool outlet. This is a crucial safety step before any further inspection. Once the breaker is off, use a non-contact voltage tester to confirm that there is no power at the receptacle and the pool outlet. This ensures your safety during the inspection. Return to the ground fault circuit interrupter receptacle and press the test button. This should cause the ground fault circuit interrupter to trip, and the reset button should pop out slightly. Now go to the outlet near the pool and use the non-contact voltage tester again to confirm that the outlet is no longer receiving power. If the outlet is indeed dead when the ground fault circuit interrupter is tripped, it indicates that the ground fault circuit interrupter is protecting that outlet. Reset the ground fault circuit interrupter by pressing the reset button. Return to the breaker panel and turn the breaker back on. Use the non-contact voltage tester once more to ensure that both the ground fault circuit interrupter receptacle and the pool outlet are now receiving power. This completes the verification process. If the outlet near the pool does not lose power when you trip the ground fault circuit interrupter, or if you cannot locate a ground fault circuit interrupter receptacle that protects the pool outlet, it is essential to consult with a qualified electrician. An electrician can properly diagnose the wiring, install a ground fault circuit interrupter if needed, and ensure that all outlets are safely protected. Ground fault circuit interrupters are designed to protect people from electrical shock by monitoring the current flowing in a circuit. If there is a ground fault, meaning current is leaking out of the intended circuit path, the ground fault circuit interrupter quickly trips and cuts off the power. This is especially important near water sources like pools, where the risk of electrical shock is higher. Regular testing of ground fault circuit interrupters is crucial to ensure they are functioning correctly. You should test each ground fault circuit interrupter monthly by pressing the test button and confirming that the receptacle trips. If a ground fault circuit interrupter fails to trip when tested, it should be replaced immediately. Furthermore, ensure that all outdoor outlets, especially those near water sources, are weather resistant. These outlets are designed to withstand exposure to rain and moisture, reducing the risk of electrical hazards. Check that the outlet covers are intact and properly sealed. Damaged or missing outlet covers can allow water to enter the electrical box, creating a dangerous situation. Finally, it's worth noting that while ground fault circuit interrupters are highly effective, they are not a substitute for safe practices. Always use caution when working with electricity, and never touch electrical devices with wet hands or while standing in water. The primary function of a ground fault circuit interrupter, often referred to as a GFCI, is to protect individuals from electrical shock. It achieves this by continuously monitoring the balance of current flowing between the hot and neutral conductors in a circuit. In a properly functioning circuit, the current flowing through the hot wire should precisely equal the current returning through the neutral wire. A ground fault circuit interrupter is designed to detect even minuscule imbalances in this current flow, typically as small as 5 mA. When such an imbalance is detected, it indicates that some of the current is leaking out of the circuit, potentially through a person who is in contact with a live conductor underground. This leakage is known as a ground fault. Upon detecting a ground fault, the ground fault circuit interrupter acts rapidly, interrupting the power supply to the circuit within a fraction of a second, usually around 20 to 30 milliseconds. This rapid interruption is crucial because it occurs before the electric shock can cause serious harm, such as cardiac arrest or severe burns. Ground fault circuit interrupters are particularly vital in areas where the risk of electric shock is elevated, such as near water sources like pools, hot tubs, and spas, as well as in bathrooms, kitchens, and outdoor locations. The National Electrical Code, or NEC, mandates the use of ground fault circuit interrupter protection in these areas to ensure safety. There are two primary types of ground fault circuit interrupters readily available. One is the ground fault circuit interrupter receptacle, which is installed in place of a standard electrical outlet, and the other is the ground fault circuit interrupter circuit breaker, which is installed in the electrical panel and protects the entire circuit. Both types perform the same function of detecting ground faults and interrupting power. Ground fault circuit interrupter receptacles are easily identifiable by the test and reset buttons located on the face of the receptacle. These buttons allow for regular testing of the device to ensure it is functioning correctly. Ground fault circuit interrupter circuit breakers, on the other hand, have a test button on the front and are designed to trip the entire circuit when a ground fault is detected. It is essential to test ground fault circuit interrupters regularly, typically on a monthly basis, to verify their proper operation. To test a ground fault circuit interrupter receptacle, simply press the test button. This should cause the receptacle to trip, cutting off power to the outlet. To restore power, press the reset button. For a ground fault circuit interrupter circuit breaker, pressing the test button should trip the breaker, cutting off power to the entire circuit. To reset the breaker, move the handle to the off position and then back to the on position. If a ground fault circuit interrupter fails to trip when tested, it should be replaced immediately by a qualified electrician. Ground fault circuit interrupters have a limited lifespan and can degrade over time, so it is essential to maintain them properly. In addition to ground fault circuit interrupters, arc fault circuit interrupters, or RFCIs, are another type of protective device used in modern electrical systems. While ground fault circuit interrupters protect against ground faults, arc fault circuit interrupters protect against arc faults, which are dangerous electrical arcs that can cause fires. Arc fault circuit interrupters are typically installed in the electrical panel and protect entire circuits. Arc fault circuit interrupters are designed to detect the unique characteristics of electrical arcs, such as erratic current flow and high-frequency noise. When an arc fault is detected, the arc fault circuit interrupter trips, cutting off power to the circuit and preventing a fire. Arc fault circuit interrupters are particularly important in bedrooms and other areas where there is a high risk of electrical fires. The NEC requires the use of arc fault circuit interrupters in many new construction and renovation projects. Both ground fault circuit interrupters and arc fault circuit interrupters play crucial roles in ensuring the safety of electrical systems. Ground fault circuit interrupters protect against electric shock, while arc fault circuit interrupters protect against electrical fires. Together, these devices provide comprehensive protection against a wide range of electrical hazards. Regular inspection and maintenance of electrical systems are essential for ensuring safety. This includes checking for damaged wiring, loose connections, and other potential hazards. It is also important to ensure that all electrical devices are properly grounded and that ground fault circuit interrupters and arc fault circuit interrupters are functioning correctly. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform electrical work. Electricians have the training and experience necessary to safely install and maintain electrical systems. When hiring an electrician, be sure to check their credentials and ensure that they are licensed and insured. A qualified electrician will be able to properly diagnose and repair any electrical problems you may have. Electrical safety is a serious matter, and it is important to take precautions to protect yourself and your family from electrical hazards. By understanding the principles of electrical safety and following safe practices, you can minimize the risk of electric shock and electrical fires. The most important aspect of electrical safety is to always respect electricity and never take it for granted. Electricity is a powerful force that can be dangerous if not handled properly. Always follow safety guidelines and seek professional help when needed. Regularly inspect electrical cords for damage and replace any cords that are frayed or cracked. Do not overload electrical outlets or extension cords, as this can create a fire hazard. Use surge protectors to protect sensitive electronic equipment from power surges. Keep electrical devices away from water and never touch electrical devices with wet hands. If you are working on an electrical project, always turn off the power at the breaker panel before starting work. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. If you are not sure how to do something safely, consult with a qualified electrician. Electricity is an essential part of modern life, but it is important to use it safely and responsibly. By following these tips, you can protect yourself and your family from electrical hazards. Understanding the specific requirements of the National Electrical Code is crucial for ensuring electrical safety and compliance in any building. The NEC, updated every 3 years, provides comprehensive standards for electrical installations, covering everything from wiring methods to equipment specifications. One of the key areas addressed by the NEC is ground fault circuit interrupter protection. The NEC mandates the use of ground fault circuit interrupters in various locations to minimize the risk of electric shock. Specifically, ground fault circuit interrupters are required in bathrooms, kitchens, garages, outdoor areas, and near water sources such as pools, hot tubs, and spas. The NEC also specifies the types of outlets that require ground fault circuit interrupter protection. For example, all 125 volt, 15 and 20 amp receptacles in bathrooms and kitchens must be ground fault circuit interrupter protected. In outdoor areas, all receptacles that are readily accessible must be ground fault circuit interrupter protected. The NEC also addresses the installation of ground fault circuit interrupters. Ground fault circuit interrupters must be installed in readily accessible locations so that they can be easily tested and reset. They must also be installed in accordance with the manufacturer's instructions. In addition to ground fault circuit interrupters, the NEC also covers arc fault circuit interrupters. The NEC requires the use of arc fault circuit interrupters in many new construction and renovation projects to protect against electrical fires. Arc fault circuit interrupters are typically required in bedrooms, living rooms, and other areas where there is a high risk of electrical fires. The NEC specifies the types of circuits that require arc fault circuit interrupter protection. For example, all branch circuits that supply 120 volt single phase 15 and 20 amp outlets in bedrooms must be arc fault circuit interrupter protected. The NEC also addresses the installation of arc fault circuit interrupters. Arc fault circuit interrupters must be installed in the electrical panel and must protect the entire circuit. They must also be installed in accordance with the manufacturer's instructions. The NEC also includes requirements for grounding and bonding. Grounding and bonding are essential for electrical safety because they provide a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. The NEC specifies the types of grounding and bonding conductors that must be used, as well as the methods for installing them. The NEC also includes requirements for wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications. For example, non-metallic sheath cable or NM cable is commonly used for residential wiring, while metal conduit is typically used for commercial and industrial wiring. The NEC also includes requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the size and type of overcurrent protection devices that must be used for different circuits. Compliance with the NEC is essential for ensuring electrical safety and preventing electrical hazards. Building inspectors typically enforce the NEC during construction and renovation projects. Failure to comply with the NEC can result in fines and other penalties. It is important to stay up to date with the latest version of the NEC and to follow all applicable requirements. If you are not familiar with the NEC, it is best to consult with a qualified electrician or electrical engineer. They can help you understand the NEC requirements and ensure that your electrical system is safe and compliant. Understanding and implementing proper grounding techniques is a cornerstone of electrical safety. Grounding provides a low impedance path for fault current to return to the source, thereby tripping the overcurrent protection device, such as a circuit breaker or fuse, and preventing dangerous voltage from appearing on metal parts of equipment. The primary purpose of grounding is to protect people from electric shock. When a fault occurs, such as a wire coming loose and contacting a metal enclosure, the grounding system provides a path for the fault current to flow back to the source. This high current flow causes the overcurrent protection device to trip, quickly disconnecting the power and preventing a shock hazard. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding involves connecting all metal enclosures, conduit, and other non-current carrying metal parts to ground. This ensures that if a fault occurs, the metal parts will not become energized, preventing electric shock. System grounding involves grounding the neutral conductor of the electrical system. This provides a stable reference point for the voltage and helps to limit voltage surges. The NEC provides detailed requirements for grounding and bonding. Grounding and bonding conductors must be sized according to the size of the circuit conductors. They must also be installed in a manner that ensures a lower impedance path for fault current. The NEC also requires that all metal water pipes be bonded to the grounding system. This is because metal water pipes can become energized if they come into contact with a live wire. Bonding the water pipes to the grounding system provides a path for the fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. In addition to grounding, bonding is another important aspect of electrical safety. Bonding involves connecting different metal parts together to create a continuous electrical path. This helps to equalize the voltage between the different metal parts, reducing the risk of electric shock. The NEC provides detailed requirements for bonding. Bonding conductors must be sized according to the size of the circuit conductors. They must also be installed in a manner that ensures a low impedance path for fault current. The NEC also requires that all metal raceways, such as conduit and cable trays, be bonded together. This is because metal raceways can become energized if they come into contact with a live wire. Bonding the raceways together provides a path for the fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements for grounding and bonding, you can minimize the risk of electric shock and electrical fires. The National Electrical Code in Section 210.8 provides details about GFCI protection. It states that all 125V through 250V receptacles installed in bathrooms must have GFCI protection. All single-phase 125V through 250V receptacles within 6 feet of the outside edge of a sink must also have GFCI protection. Dishwashers also must have GFCI protection. Cord and plug-connected appliances such as vending machines must also have GFCI protection. Laundry areas also have to have GFCI protection. The 2023 NEC requires GFCI protection for specific outlets within 6 feet of sinks in commercial and industrial locations. This rule expands GFCI protection beyond residential settings to enhance safety in workplaces where water exposure is common. All single-phase 125V through 250V outlets within 6 feet of the sink's edge must be GFCI protected to minimize electrical shock risks in environments like commercial kitchens and labs. Additionally, Section 210.12 of the NEC, arc fault circuit interrupter protection is required for branch circuits that supply 120V single-phase 15 and 20 amp outlets in bedrooms, living rooms, dining rooms, family rooms, recreation rooms, and similar areas. The purpose of arc fault circuit interrupters is to protect against electrical fires caused by arc faults.